All right, welcome back. Training module 4.2. This is part 4. This is technical tips for Supermini and Mini application. I'm your trainer, Edwin Tunney, training and technical specialist for Horn USA Inc. The first thing I want to advise about on Supermini and Mini is we talked about in the last part of the training about cutting parameters and just how critical those are. And you will notice to get achievable good surface finish on a part that you have lower cutting feed rates. And the reason for that is just the physics of this formula. So your surface finish in RA is the result of the feed squared divided by 24 times R and then multiplied times 100,000. So sorry, 1 million. So that surface finish is fixed by those parameters. So the two parameters that you have control over are the feed and the radius. Uh, to a lesser degree, the cutting speed has an effect. You can have material redepositing on your surface if you're not using the proper speeds, and then stability. So stability, if it's not stable, you have really no hope to have a surface finish, a consistent surface finish throughout the part. So if you look right around, if your radius sizes, which for the Super Mini and Mini, a lot of the radius sizes you'll notice are 8 thousandths. They can be 4 to 8. Most of them are right around 8. You will see that in order to achieve a 20 RA, you need a 2 thousandths per rev feed rate. It's a little different than if you're used to an ISO world with a CNMG 432, for instance. You can run much higher feed rates and still achieve that 20 RA finish. So, for instance, if you have an 80 thousandths radius, a really big radius, you can achieve that with a 6 thousandths feed. Now, um, that's not to say we don't have some solutions. We saw in a prior training, not talked about in the applications, but with Super Mini HP, you have a wiper facet on the side, and we certainly do create a lot of made-to-order inserts with wiper technology where you can get a little bit higher feed rate and still achieve 20 RA or better. So just keep that in mind. The two parameters that are the most influence on your surface finish are the radius size and your feed per revolution. Also want to talk about why certain cutting conditions are different than others, and just to get your mindset on why that might be. So for a grooving situation, the problem in grooving is really you have a big cutting section. Your feed per rev might be sort of lower, but oftentimes you have a big cutting section across the cutting edge. You have a lot of cutting edge in contact. So the force direction really means high deflection. So you're pushing against this tool. Your section is high, and thus your forces are high. The forces involved in any kind of machining process are really the material, but also the area. So as this cross-sectional area increases, your force increases, really no matter what material you're running. If you look at profiling or boring, um, the feed direction, the cutting section is fairly low because you're not generally taking the full edge of the tool, nor should you. So you have sort of medium deflection. Your section is low, and your forces tend to be lower. You have lower forces and they're favorable because they're being pushed in the axis here of rotation and not perpendicular. So they're nearly parallel forces to um, the axis, so much lower and more favorable. If you look at face grooving, so face grooving is kind of between the two because it has a big section, so you have a big cutting section. Your force direction is favorable, so that means low deflection, so that's a good thing. But your section is high and your forces tend to be higher. So the saving grace um, on face grooving is that your axis of rotation and your forces are parallel, but then you drag it down a little bit with the cross-sectional area that you have to take each revolution. Keep in mind also with Supermini especially, and to a lesser degree the Mini, you're dealing with fairly small edge preps. So you want to, that's an advantage to have a very positive cutting edge with a small edge prep, but it's a disadvantage if it's not used properly. If you're trying to like cut through cross holes or interruptions, that can be very problematic and needs to be handled correctly through lower cutting parameters. So always just keep in mind, edge preps they're intentionally designed to be very up sharp and free cutting, but just be careful when you're dealing with any kind of interruptions or things that aren't good for sharp cutting edges. So in previous presentations, we saw a lot of geometries, and things like that. But what do you do if a geometry doesn't help with your chip control and you're having issues? Um, you can implement different strategies and processes. So the first one we see here is called speed peck. So speed peck is nothing more than taking small plunges into the material and then retracting and doing that over and over until you reach your groove depth. So you want to start that process easy way, divide your total depth of your groove, divide that by 15 thousandths, and that's how many inches per plunge you're going to use. You plan your process out so that you only retract about half your feed per rev. So if you're feeding at 3 thousandths per rev, then you want to retract at 1.5 thousandths per rev. Repeat the process using a macro or can cycle until that depth is achieved. So you can use a dwell function also rather than retracting, but be aware that the dwell function actually puts more heat into the process and thus more tool wear. Another little quick or fairly easy tip on how to use the tools properly um, is to plunge to below the chamfer. And the reason you do that is with really with Super Mini or Mini or any kind of grooving tool, you really don't want to cut in multiple sides of the tool at the same time. So you want to cut with one side of the tool at a time. So the process here will help you do that. So step one is you plunge to just beyond where your chamfer is on your part. So you're gonna have a groove and you'll have some kind of chamfer, whatever depth that is. You plunge, then you retract. Then you enter the part and you're only cutting on the bottom and you're actually generating the chamfer. Then you move to the other side, generate the chamfer, and then you go and do the full plunge, at 5, and then retract at 6. So basically, just 2 extra little moves will help give your tool the best tool life and the lowest stress on the cutting edge. If you're plunging out a groove that takes multiple steps, so you can have this situation if you do have a chip control problem, and if you do have a chip control problem and you need to break up the groove in with a smaller groover, so you're going to take multiple passes and thus make the chip a little bit smaller, you can do that using this process. So always plunge out the center first. So you're going to plunge and then retract, and then you can do your chamfer. Since you're not cutting on this side of the part anymore, you can chamfer, then plunge, and then do on the right side, chamfer and plunge. And lastly here, just a quick, just a troubleshooting guide. So one symptom that you can have with the Supermini is it's not on center. The very first thing to try with Supermini is install a new clamping screw. The first thing to try with the Mini system would be to make sure you have that 4/1000 gap. Because if you don't have if the clamping screw is bad on the Supermini system and you don't have that gap on the Mini system, chances are things are moving around and it might not be on center. You can also try replacing the lathe block screw, and then check the insert and body clearance on the Mini. So just as mentioned, check all the machine alignments. So often we assume that things are aligned, and then we find out that someone has crashed the machine or something's gotten knocked out of alignment. Always on a regular basis, you should be checking your machine alignment. Breakage. Breakage, check the center height. So if your center height is bad, that can cause a breakage of the tool. Check for any clearance issues. Look back and make sure that the tool that's chosen has enough clearance. Are you having chip jamming problems or those kind of things? 9 times out of 10, lowering the cutting speed or the cutting feed, you're not going to go from breaking the tool to not breaking the tool just based on that. It's generally a problem of clearance when something is snapping or breaking off. Excessive wear, reduce speed, check the center height. Chipping, check for chip recutting is the first and foremost thing, and then reduce your feed, increase your coolant pressure, and that's just getting the chips out of the way in a better so that you're not chip recutting. Poor surface finish, use a shorter L2, increase your speed, reduce your feed. As mentioned, the feed and the radius have the biggest influence. Check the tool alignment, increase your radius if you can. You can get a made-to-order product with a bigger radius, or attack it using a wiper insert, for instance. Poor chip control, you want to use a chip breaker, use speed peck, use multiple groove widths. So don't always fixate. I've got a 3mm groove and I must use a 3mm width groover. If it's necessary, use a 1mm and take 3 passes, or a 1.5 and take 2 passes to get the chip under control. Increase your feed. So put a little bit more pressure on the cutting edge to make the chip curl and break. Built up edge, increase your speed. Check the coating compatibility with the workpiece. So make sure coating is slick enough for that material. Aluminums tend to be the worst. Brasses and coppers, things that are sticky, they stick on the cutting edge. So make sure that your coating is slick enough for that. Edge deformation, decrease your speed, first and foremost. And then if you don't solve the problem with these, we have resources inside and out of Horn. So contact your Horn sales and application engineer, or you can contact Horn technical support if the problem isn't resolved. So we're here to help you and make the best use out of your tools. So make use of those resources. All right, that concludes part 4 of our series on Supermini application. I hope you enjoyed your time. Check back here for future training recordings. Subscribe to the channel, and then you'll get an alert. And have a great day.